solve another Leetcode problem, 12012, smallest string with swaps. So I solved this problem a few hours ago. Now I go back and trying to explain it. So this time I'm not going to write the code, but I will explain why I did it like this. So let's first try to understand the problem, smallest string with swaps. So we are giving a string S, but inside for this string there will be letters, and strictly it is lowercase English letters, and we have a pairs array. So inside the pairs it's gonna be a pair, so each pair with two indexes. So for the first index it is 0, the second index is 3, so for the first pair. So this means from index 0 to index 3 it can be swapped. So for example, this D and B can be swapped to B and D. And similarly, the second index and third index, so index 1 and index 2 can be swapped. So CA can become AC. So this is the final result, BACD. And we cannot find a smaller sequence like starting with A. It must be starting with B and A, C, D. So how should we find this result? So first of all, we need to translate the problem to our basic models. So the model is like that. Let me explain a little bit from let me explain a little bit from here. So the problem is we are giving a pair like A and B. So this A and B, so this index means 0 and 3 can swapped. So if this A and B can swapped, and then I have a B and C can also swapped, then the A and C can also swapped. So this is the problem. If there's some property like this, so it means it is a connected component problem. So this means if A and B can swapped, so this means A and B will be connected together. And if B and C can swapped, so B and C will be connected together. So after that, so for A, B, and B, C should be connected to A, B, and C. So this means this A and B and C together can swapped. So according to this property, we can use unified to solve the problem. So for the unified, basically if we are giving A, B, and B, C, so basically the A, B, C should be connected together. So this means inside the A, B, C, any pair can be swapped. So this A, B, C can become the permutations of the result. So you know A, B, C, for the permutations of A, B, C, there are 6 results. But for this problem, they are not about the permutations. They are just, you just need to know this A, B, C should be connected. And then let's try to use the unified to solve the problem. So let me first explain the unified. So for the unified, you can prepare any template as you like. But for me, I will prepare this kind of a template. I will not use rack. I will not use racking. And basically here is a very basic path compression. For the file. And the union is just connected to parent. So this is the parent 1, parent 2, it is for n1, parent 2 is for n2, just connected it together. And this connected, I just prepared another function for connected, is just for checking if n1's father equals to n2's father. So this means they are connected. So if they are not connected, I'm gonna union it. So this is just some basic template. And the hard part is about how to translate the problems to the unified. And inside the pairs, we know that inside the pairs, these numbers like 0 and 3 always be the indexes of the string S. So we should know that the number inside the unified should be length of the string, because we will use unified, we will use these numbers to represent the node. So the minimum and maximum node should be 0 to n minus 1. N is the length of the string. So we can use the length of the string as n and put n inside the unified. Now we can put all the answers inside the pairs and make it and make them connected. So if they are not connected, I gonna use a union to make them connected. Or I cannot, even I don't use this one, it is still okay. So I just let it, let the algorithm works faster, because if they are not connected, so I need to connect them together. So I need to use union. So if they are already connected, so basically I don't need to run the uf.union. But basically you can also delete this line. It doesn't matter. But for logically speaking and make the algorithm a little bit faster, we can use this. If they are not connected, we can use the uf.union. And the hard part is so this is basically the template. When you prepared everything about the template, the hard part is how you can translate your problems to the unified and how you can solve it. Let me explain a little bit about how I will solve the how I will solve the problem. As I explained earlier, we find some A, B, C if they are connected. Now let's use some index. So for example, if we use index, like if the index is 0, 1, 2, and 3, if these 4 indexes are connected, and what about the letters inside? So for example, if the letters just randomly, BA, maybe C, maybe DC, So this is the index. So while we are using the unified to connect all the indexes like 0, 1, 2, and 3, so so for each of the index, so there's a string s. So I just turn this string s into an array. So for the letters, it will be like BA and D, C, or DD. It doesn't matter. Let's just make it BA, DC. So it means inside these 4 positions from index 0 to index 3, we need to put A, B, C, D inside. So for example, we need to put A, B, C, D inside. But how should we put A, B, C, D inside these positions? So this is a little bit difficult for beginners to use the algorithm. So actually we can use a sort. So for example, we have a BADC. After sorting for this BADC, so we will get ABCD, because the letters after sorted, it will be like A, B, and C, D. So what about the positions? So the positions should also be sorted. I mean the index should also be sorted. So here it is like 0, 1, 2, 3. If it is like 1, 0, 2, 3, it should be sorted to 0, 1, 2, 3. And then after sorting, this is 0, 1, 2, 3, we can put the positions for the 0, we're gonna put A, and and for the 1, we're gonna put a B. For the position 2, we're gonna put a C, and for position 3, we're gonna put a D. So this means we put all those A, B, C, D to the right positions. So this is the difficult part. Now let me explain from here. So I'm gonna use a dictionary. So I'm gonna check the connected component. So inside of the dictionary, it will be the connected component. So this is a duf dot find I. It means I will use all those indexes and put it. So for example, the find I, the father, maybe it is index 0, but inside I will append the index. So this is basically a default dict list. So inside it will be list. So it means inside here, while I put it inside, it will be something like this. Something like 0, 1, 2, and 3. Inside it will be indexes. Now let me print out the D. You will see what it looks like. Now let me just print out the D. D just means a connected component, but here we will use index to represent it. You can see here, for the first example, inside of the pairs, this index 0, 3, so means, this is the father. So the 0, this is the root node. So for this root node, this means 0 and 3 are connected, and here is 1, 2. So 1 and 2 are connected. Let's try to see another example. So for the second example, we know the 2 is farther, but it doesn't matter. We're just considering the connected. So the connected component is 0, 1, 2, and 3. Yeah, so this is the meaning of the dictionary. So inside the dictionary, the values means the components are connected. So we just enumerate all the values. So for the first value, it is an array. For example, this is 0, 1, 2, and 3. So we should sort the array because inside it is not sorted. So this is just an example. It is sorted. For example, let's check another example, maybe example 1. Or it is sorted accidentally, I believe, but normally it should not be sorted. So we need to sort the array. So after sorting the array, this means the index should be sorted. Yeah, I think this index is also sorted. Yeah, I think this is also sorted. Basically, I don't need to sort, but let's just make this array sort the array. This means the index should be sorted, and also the letters inside the index should also be sorted. Like from the beginning, it is B, A, D, C. We should sort it as A, B, C, D. So we need to take it out. So we need to take out the index from the array and get to the letters. We use SI to get the letters. So we get the letters like B, A, D, C. And then we sort the array. So this sorted letters means this array should be sorted. And now we just use another loop, just to put the right index to the right letter. So for example, the first index is 0. The S array 0 means index 0 here. And we got the letters, sorted letters I. So after sorting, it is A. So for the first position 0, we put a A. For the second index 1, we get a B. And index 2, we get a C. And the last index, we get a D. So this is the idea. Yeah, and here I don't think I need to sort it because while I'm using this dictionary, basically I believe I put the I inside. This I should be sorted. Yeah, but just let's run the code to check if it works. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases. Yeah, but let's just delete the sort. So this time, I think I don't need to sort the array even because this index should be sorted inside the array. Now let me run it and check if it works. Yeah, now let me submit it to check. Yeah, as you can see, it works. So this is why this is so important. You need to yeah, while I'm solving the problem, I think it is okay. But while I'm going to talk about it, I find, oh, there's some code I don't even need it here. Yeah, I don't even need to sort the array because the index has already been sorted by here. Yeah, so this is one thing. And for another thing, maybe we can also improve a little bit for the unified template. Yeah, so for the template, we can also added a racking. So basically, there are path compression and racking. Yeah, we can use a racking to improve the efficiency of the algorithm. If we don't use it, basically this is a n log n. But if we use the racking, it will be on. Yeah. So the n is the length of the string. So by using the racking, the time complexity will be on. Now let's just recover it and use the racking to check if it works. Yeah, basically this is also a template. This is the most used template. Yeah, I used for solving the unified problem. Actually, there are many templates. Yeah, I used 3 or 4, but this is the mostly used template. And the racking is we just need to prepare a rack. And inside from the beginning, it is 1. So this means I already have a node. There's only one node in my component, so it is 1. If there are 2 connected components, so my racking will be 2. Yeah, so this is from the beginning. And here is just needed to check which racking is bigger. Yeah. So if P1's racking is bigger, so I need to P2's parent should be connected to P1. So this means if this is P2, from P2 I should connect to P1. Yeah, this is just for prepare a balanced binary tree to make the algorithm of union or find make it faster, nearly O1 for the union and find. Yeah. Now let me just run it to check if it works. Yeah, as you can see, it works, and it's really fast. It's much faster than before. It's already 200. Yeah, but it always depended on you. Yeah, if it's some algorithm you cannot pass it, maybe you should use the racking or path compression. Thank you for watching. See you next time.